Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Hello guys, good afternoon. 27th of February today 2021, and now we are into the lecture number 15 of control system, in which we are going to discuss what are the special cases of Routh-Hurwitz's stability criteria. In the previous lecture we have discussed what is Routh-Hurwitz's stability criteria and how the stability can be tested using Routh-Hurwitz's stability criteria. Okay, so there are some special cases into this. So before we go further, let me introduce myself. My name is Rajat Kumar Jain. I have qualified GATE with AIR 212 in instrumentation engineering in the year 2012. Beside that, I have qualified various PSU tests, among them BARC, IBPS and JEE. Naming some of the few names I have included. Beside that, I am pursuing PhD. I am having 10 plus years of teaching experience and have mentored more than 10,000 students till now. And I usually take 5 to 6 subjects of GATE, including industrial instrumentation, electrical measurement, control system, digital electronics, process control, optical instrumentation. And how you can connect with me and other top educators of the country. You can use code RAJAT11 to access free live classes, as well as you can get 10% additional discount by using this code. So guys, to connect with me over Unacademy, you have to use RAJAT11 code. Okay, so you can take two kinds of subscription, plus subscription and iconic subscription. The plus subscription gives you the benefits of live classes, crash courses, weekly test, doubt solving sessions. In classes are in both languages, English and Hindi. So the candidates having problem in attending Hindi classes, they can join in English class. and those who are having problem in attending Hindi classes, they can join, they can English class, they can join in Hindi class, right? There is no problem. Now you can also have the benefit of all these plus advantages into Iconic subscription. In additional to those benefits, right, all these benefits are covered by the Iconic subscription. Additional to those benefits, the Iconic subscription is having personal coach, study planner, study booster, personalized test analysis, dedicated doubt clearing instructors, preparatory study material, right? Preparatory study material, this can be used for lifelong. So this is the biggest advantage of Iconic subscription. Personalized test analysis to assess your GATE preparation, in-depth preparation, how much you are doing, this can be assessed by personalized test analysis. So guys, don't wait, just subscribe for Unacademy. Use my code RAGAT11 for the subscription. So what you can do, you can simply install the Unacademy learning app. You click on install, you register onto the app with your mobile number and email and your name, and go into the manage goals section where you can find the GATE and ESE segment. Under GATE and ESE segment, click on plus and then click on get subscription. So you will be prompted for selecting any particular subscription plan. What is that subscription plan? It may be of 12 months, it may be of 24 months, it may be of 6 months, it may be of 1 month. There are variety of subscription plans are available. Just apply the demo code of mine, that is RAGAT11, and click on proceed to payment. The payment summary will be available. And the best thing is that Unacademy is the only learning platform in the country who is giving this option of EMI, payment in terms of EMI, right? So this can be done, the payment can be made with the no cost EMIs with various debit cards and credit cards. So guys, basically we are providing the two kinds of subscription, plus and Iconic. The plus subscription is available for 12 months, 18 months and 24 months, and you can see that it is available for a low cost EMI as possible as this one. You can use my code RAGAT11 to get additional 10% discount. Similarly, the Iconic subscription is available for only 12 months and 24 months duration. The guys, those who are in second year, they can plan to join 24 months subscription. Those who are in third year or final year, they can join for 12 months of subscription. Now the guys, please note that with one fees, you are having advantage of two courses, GATE and ESE. So that's a really good thing, that using by paying one fee only, you are getting the knowledge of two courses. The guys, we are starting our new batches from 1st March where 2021 for GATE 2022 and GATE 2023 for both electrical and EC engineering. By default, IN engineering is included in this syllabus. So the instruments, the students who are instrumentation engineers, they can also join this particular batch, right? So Ankit Goyal sir, Vishal Soni sir, Suresh VSR sir, BV Reddy sir, Kezer Hafiz sir, Bhima Shankar sir, Ajay Gupta, Varun Srivastav, S. Vishnu sir, all these are very experienced faculties. Some of them are have qualified GATE with AIR 1, right? And some of them are IES qualified IES examination. Some of them have been into IIT. Some of them are working with PSUs. So you can have advantage of all these team of Unacademy. Okay. Again, you can use my code RAGAT11 to get additional 10% discount. Don't forget to apply my code RAGAT11. The batch name is GATE Evolve for 2022. That is batch E. Then the batch E again for GATE 2023 and for GATE 2023 also electrical engineering and EC engineering. Alright. So guys, let's start with today's discussion. That and you can follow me on Unacademy at unacademy.com, at RajatKJN1708 to access my live free classes, as well as the plus special classes, and Unacademy GATE English. This is our Telegram channel. You can join this channel. Around 1200 subscribers have already joined this Unacademy GATE English channel. More than 5000 subscribers have joined it YouTube channel. So join these two channels for all the better updates. And this Telegram channel gives you the benefit in terms of lecture notes, right? The YouTube links, the video links, the information about quiz and recruitment processes. So guys, control system lecture number 15, RH criteria special case 1. Special case 1, RH criteria special case 1. On in the second lecture we will be covering the problems on GATE and special applications of RH criteria. Okay. So before we go further, let's start our discussion with a wonderful quote. The expert in anything was once a beginner. No doubt about that. That's a really important thing. Those who are we assume that this person is expert in this particular subject or this particular topic. So once he was a beginner. So for becoming expert in control system, we have to begin with right? So we have to begin and we have to go into the deep and we have to become expert, right? Our expertise is to make you expert of a particular subject, and that's what we at Unacademy are doing continuously and sincerely. So review of stability concept, this we have discussed in the previous lecture, right? What is stability? Stability, that means the roots are lying into the left half of S plane. If the roots are lying into the right half or they are lying onto the imaginary axis, the system is called as unstable and marginally stable respectively. Next is the location of roots, how it is characterized and says the response. So when the roots are on the imaginary axis, the response is oscillatory. When the roots are on the left hand side, the response may be exponentially damped response, negative damped response, or it is simply damped response, right? Sinusoidal, it is not sinusoidal response, it's a sinusoidal damped response, it's a simple damped response. This type of response we are going to get, and here we are going to have increasing magnitude of oscillation as well as increasing magnitude of output. So it is strictly prohibited for a design purpose of control system. The roots are should be located into the left half of S plane, that we have seen yesterday. Then the characteristics equation of simple feedback system can be written as this one: 1 plus GSHS equals to a n s to the power n plus a n minus 1 s to the power n minus 1, and so on. Two necessary but insufficient conditions for looking the stability is that all the coefficients should have the same sign and none of the coefficients should vanish. But merely looking this possibility, we cannot say that the system is stable. So the Ruth and Hurwitz both suggested a mathematical tool for analyzing the system stability. So what is RH criteria? It is a algebraic method, provides information on the absolute stability of linear time invariant system that has a characteristics equation with constant coefficients. Indicates whether any of roots of characteristics equation lie in RHS plane or not. And indicates the number of roots that lie on the j omega axis and gives the range of some system parameters over which the system can be stable. Right? So how to form the Ruth array? Yesterday we have seen this procedure, how to form the Ruth array. Indeed we did the numerical. So the procedure is very simple. What we have to do, we have to form the characteristics equation. The first two rows of the characteristics equations are directly taken. First two rows of the Ruth array are directly formed using the characteristics equation, and then the subsequent arrays are formed. Subsequent arrays are formed by making the Hurwitz polynomial. That is this one, B1. B1 is a1 into a2 minus a0 by a3 divided by a1, and it will continue for obtaining all the coefficients. As we are increasing the array, the number of coefficient reduces down the order, and s to the power 0 coefficient will always remain the same, which is present over here, that is represented by an, right? There is no change in s to the power 0 coefficient. So yesterday we saw that how this array is formulated, right? You can see that once again. B1 is A1 A2 minus A3 A0 by A1. Next is your B2, that is A1 A4 minus A0 by A4 by A1. Similarly, B3 can be calculated, A1 into A6 minus A0 upon A7 divided by A1. In turn, you can just do that also. You can reverse the sign, A7 minus A1 A6, and then you can divide by minus of A1. This is also true. Okay, just remember this. Now B1, B2 and B3 are available, then we can compute the value of C1, C2 and so on. Right, so C1 will be A1 B1 into A3 minus A1 into B2 divided by B1. You can see that. Similarly, the value of C2 can be computed. B1 into A5 minus B3 upon B1, that will be C2. Now this coefficient is not available. Hence, this coefficient will become directly the value of A7, and so on the coefficients can be calculated. So as we go on approaching towards s to the power 0, the process is repeated till the last row is obtained. S to the power 0, the number of coefficient reduces by 1 in each of the rows, right? The necessary and sufficient condition, that is stability criteria. What is the stability criteria? All coefficient in the first column of Routh-Hurwitz array must have same sign. Right, now you will be asking, sir, why we are doing this all stuff? Because simply by looking at the characteristics equation each time, it is not possible for us to determine the root, because something of power of s to the power 4, it will take very much time to solve that particular equation. First of all, we have to convert that equation into a square equation, then we have to find out the roots, and then we have to apply it. And even if the value of s to the power 4 increases beyond that, then what we will do about that particular equation? How we will be solving that particular equation? That will be becoming very difficult for us to investigate where the roots have been located. That's why the Routh array has suggested a very lenient method, very simple method for determining the absolute stability of the system. So we have to check whether the sign in the first column is same or not. If it is same, the system is said to be absolutely stable. If it is changing, then number of sign change equal to number of roots lying into the right half of S plane. If it is changing, number of sign is equal to number of roots lying into the right half of S plane, right? When there are sign changes in the first column of Routh's array, then the system is said to be unstable. There are roots in RHP. The number of sign change equal to number of roots in RHP. So for an example, there are two sign changes, or suppose there are B number of sign changes. The sign changes are B, and the order of the equation is n. So n minus b will now located in LHS and b will be located in RHS. That's the thing. So exactly we are not going to get any information about where the root is located, but this is very confirmed. This is very confirmed that what is confirmed that the roots will be located in the left half or right half depending on the sign change. The special cases of RH criteria. So yesterday we discussed that how we can we solved some problem. We saw that how we can apply the Routh-Hurwitz criteria. Now there are some special cases. So there are two special cases. First element of a row is 0 and entire row above row s to the power s entire row above row s to the power 0 is 0. There are two special cases that we are going to discuss in this particular lecture today. So what is the first case? Let's discuss that. The first case is first element of a row is 0. That is, you can see, you can examine this comment using this particular system equation. S to the power 5, S to the power 4, 2, S to the power 3, 2, S to the power 2, 3S plus 5 equals to 0. This is our characteristics equation, which is resulting from the form 1 plus GS equals to 0. Now I am forming the Routh array from the first two rows of Routh array directly formed from the given equation. So 1, 2, 3. We can have this. Then 1, 2 and 5. We can have this, right? So now since these two rows are same, 1 into 2 minus 1 into 2 is going to become 0. If it is 0, then the next row element we will not be able to calculate, because what is going to happen when we are going to calculate the next row? 0 into 2 minus 1 into minus 2 divide by 0. The divide by condition 0 cannot be achieved. That it is going to become infinity, right? And then now we have to check the sign of that particular case. So that is what known as when the first element of any row is 0, then the rest of the row is non-zero. Rest of the row is non-zero. That means we are not able to calculate non-zero. That means simply says that we are not able to calculate that particular coefficient. We are not able to calculate that particular coefficient. So case 1, when the first row of any row is 0 and the rest of row is non-zero, here the next row cannot be found as division by 0 will take place. No doubt about that. Method to overcome. So there are three methods to overcome this. One of the method I have discussed here. Two of the method you can try. There are three methods. First method is we can replace S by some variable Z or some variable X. Any variable X. Now we can complete the entire Routh array and we can apply the entire Routh test in terms of Z or X. Please note that, guys. Please concentrate and please focus onto this. There are three methods to solve this particular problem or method to overcome this particular problem. First method is we can replace S by inverse of certain variable such as 1 upon Z or 1 upon X. Then we can do another thing. We can multiply the entire row by some constant S plus A. And then we can apply the Routh array where A can vary from 1 to infinity. A can vary from 1 to infinity. That means simply I can multiply, the simplest thing I can multiply by S plus 1 the entire row, and I can complete the Routh array now, and I can check the stability or regarding the coefficient sign in the first column. The third method that I can apply is I can simply replace that 0 by some positive coefficient epsilon or sigma, and then I will be checking the stability by applying the limit sigma tending to 0. I will be checking the sign. So there are three methods to overcome this particular problem. Right now explaining one method. These two methods you can try. These two methods are very easy, right? All the three methods are very easy, but the thing is that for the time being we can try these two methods. You can just remember, once again I am repeating what I have said. Please guys, please pay attention and just remember all these three methods. To solve this problem of problem of first element 0, first method is we can replace s by some inverse of variable 1 by z or 1 by x and complete Routh array in terms of that variable z or x, right? Second method, we can multiply the entire array s by some another pole s plus a, multiply with, rather I should write like that, multiply the equation with s plus a and complete Routh array where a can be 1, 2, 3 and so on. Third one, replace 0 by positive coefficient sigma and use limit sigma tends to 0 to investigate the sign, to find the sign. So you can use these three methods, guys. You can use these three methods for determining the stability. Okay, so let's find out the first method we are discussing. The method to overcome above problem is to replace s by 1 by z and complete the Routh's test for z. You can see that it has been done over here. 1 upon z to the power 5, 1 upon z to the power 4, 2 upon z to the power 3, 2 upon z to the power 2, 3 upon z plus 5. Now the row is formed in terms of z. 5 z to the power 5 plus 3z to the power 4 plus 2z to the power 3 plus 2z to the power 2 plus z plus 1. Use above characteristics equation and completes the Routh array test. Now you can see what has happened now. Now you can see the problem was, what was the problem earlier? Why the row of 0 was why the first element was getting 0? Because the first two signs of the two rows, first two elements of the two rows are common and the next rows are elements are not common. So we have, what we have done, we have just inverted the entire row. We have just inverted the entire row. You can see that the entire row has been inverted. 5 to 1, 3 to 1, it has eliminated that concept of becoming the first element 0, because now the first two elements are not common, 5 2 and 3 2. So this is not going to become 0. If it is not going to become 0, then the next row elements can be easily determined, right? So we have determined the next row's elements, and now you can see that there are sign changes, plus 2 minus and minus 2 plus. So two sign changes. So out of 5 rows, out of 5 poles or 5 roots, 2 of the roots are lying into the right half of S plane. That means the system is becoming unstable. That is how the stability can be determined. This could have been done in that manner what I have said earlier also. Let's take that example also here by simply replacing this 0 by sigma. What we can do is we can replace by sigma and we can comment down to the stability. Let's take that example also here itself. S to the power 4, s to the power, just creating that particular Routh array once again. S to the power 4, s to the power 5, s to the power 4, 1, 2, 3, 1, 2, 5. Then s to the power 3, s to the power 2, s to the power 1, s to the power 0. So this, say I am assuming it to be sigma, because it is going to become 0, then this coefficient is 1 into 3. 1 into 3 and minus 5. So minus 5 by 1, that is minus 5 plus 3 minus 5, that is minus 2. This coefficient is minus 2. Now this coefficient will be calculated in terms of sigma. So it is 2 sigma plus 2 divide by sigma, and this coefficient will become sigma into 5, sigma into 5 into minus 0 divided by sigma, that is going to become 5. Now the s to the power 1 coefficient will be, what will be s to the power 1 coefficient? Let's compute that also. So s to the power 1 coefficient will be 2 sigma plus 2 multiplied by minus 2 minus 5 sigma divided by 2 sigma plus 2 divided by sigma, and s to the power 0 coefficient will be same, that is 5. So these are the two what these are the three rows or three elements which are dependent on the value of sigma. So now we can apply limit sigma tending to 0 and we can find out the root stability criteria. So that is what limit sigma tending to 0. So 1 1, now it will be 0. Now limit sigma tending to 0 for this particular case, that is 2 sigma by 2. So 2 sigma by sigma, sorry, 2 sigma by 2 by sigma. So that is 2 upon 2 plus 2 by sigma, limit sigma tending to 0, that means 2 plus infinity, that means infinity. We are having a positive value over here, positive infinity, right? Positive infinity, this is 0, positive infinity. Then 2 sigma plus 2, let's check the sign of this particular element. 2 sigma plus 2 into minus 2 minus 50 minus 5 sigma, minus 5 sigma, and divide by this entire arrangement. 2 sigma plus 2 divide by sigma. Okay, so let's do divide this. If I divide this, then it is going to become only minus 2 is going to remain present. Then here it is minus 5 sigma divided by 2 sigma plus 2 divided by sigma. That is going to become right. So let's apply the limit sigma tending to 0. We can apply over here for this particular coefficient. If limit so I have to take common sigma here, right? If I take common sigma, it is going to become 2 plus 2 by sigma, 2 plus 2 by sigma minus 2 minus 5 sigma upon 2 plus 2 by sigma. If I applied limit sigma tending to 0, right, so this is going to become 0. Anything divided by 0, it is going to become 0. This complete is going to become 0. This completely is going to become 0. And now we are going to get a sign over here as minus 2. Minus 2. So sign changes there. 0, infinity, minus 2 and 5. That is, this approach is also correct. This approach is also correct. We are getting two sign changes. That's why the system is said to be unstable. So those two methods I have explained to you, right? You can use these two methods, or you can use the third one also, that you can multiply the entire equation, given equation, by some root, that is s plus 1, and again you can form again the Routh array and you can apply the Routh test for determining the stability. Okay guys, next is second case. If what happens if entire row of 0 appears above s to the power 0? S to the power 0 is not considered, right? Entire row above s to the power 0 is 0. Then what will happen? How to solve this particular problem, right? So see this case by this particular example. S to the power 4 plus 6s cube plus 11s square plus 6s plus 10. This is our equation. Now 1, 11, 10, 6, 6, 0. B1, B2, C1, AN. So B1 is computed as 10 because 6 into 11 minus 6. 66 minus 6 divided by 6, that is going to become 10. This is B1, and B2 is what? 6 into 10 minus 1 into 0 divided by 6, that is going to become 10. So B1 and B2 both are 10, right? So quite obvious. If all the elements are same, so definitely the next element is going to become 0. 10 into 6 minus 10 into 6, that is going to become 0. No doubt about that. This is 0. This is 0. So this entire row of 0 is appearing before s to the power 0. So now how to solve this problem? How to overcome this problem? Now there may be a question in your mind that if row of 0 is appearing, that means practically what does it mean? Practically it means that If row of 0 appearing, that means the system is marginally stable or unstable. It cannot be absolutely stable. If the row of 0 is appearing, that means the system cannot be absolutely stable. It is marginally stable or unstable. We have to check whether the system is marginally stable or unstable. Alright, so let's find out that. How we can do that? What is the solution to the problem? Right, case 2, when all elements in any row is 0. So case 2, when all elements in any row is 0, method to overcome, here we have to form an auxiliary equation with the help of the coefficient of the row just above the row of 0. What is that auxiliary equation and how we are going to form that? We are going to form, this is the row of 0, so we have to form the auxiliary equation using this row above 0. Auxiliary equation will be formed using this. We will be deriving it, auxiliary equation, then we will be finding the new coefficients, and those new coefficients will be replaced by this particular zeros, and then the root array can be completed, and the sign testing can be done. Okay, so here we have to form an auxiliary equation with the help of the coefficient of row just above the row of zeros. Hello guys, good evening, good afternoon. Those who are attending this particular control session, once again I am welcoming them, and for the sake of your ease and benefit, I have reduced the lecture length to only 45 minutes. Now only we will be having only 45 minutes lecture. One lecture will be of 45 minutes, then subsequently it will be very easy for you to understand the concept in the 45 minutes and try to grasp the concept, try to avail this free opportunity which we are giving to you. Okay, so here we have to form an auxiliary equation with the help of the coefficient of row just above the row of 0. Take the derivative of this equation and replace its coefficient in the present row of 0, and then proceed for Routh test. That we have to do. Okay, see here how it is done. So this was our auxiliary equation. It is formed auxiliary equation like this. As is equals to 10s square plus 10. Each term of next column differs by degree 2. You can see that each term of next column is differing by degree 2. Its degree is 2, its degree is 0. Right? Then the next derivative of this 20s. So next coefficient is going to become 20. S to the power 1 coefficient is going to become 20. Now this row can be completed. If it is 20, then the next this is going to become 10. So this now complete row is completed. Now we can see that there are no sign changes. That means the system is marginally stable. And to find out the root location, we have to solve the auxiliary equation. That is, what was the auxiliary equation? 10 square plus 10. If we solve it, it is going to become so guys, it is going to become plus minus j omega plus minus j1, right? Omega is 1. This root value of s equals to plus minus j1. That means two of the roots are lying onto the imaginary axis. Remaining roots are lying onto the left half of s plane. Just remember this concept. This is very important, right guys? This is very important. Okay. There is a power cut in my side. Okay guys. So we will be just discussing once again what we have done. We have to form an auxiliary equation. The auxiliary equation is formed by taking the row which is just above the row of 0. Alright. Just above the row of 0, we have to form the auxiliary equation. We have to differentiate that auxiliary equation. And after differentiating the auxiliary equation, the new row coefficient will be formed in terms of s. That we have to replace that 0 by the new row by the auxiliary derivative of the auxiliary equation coefficient. Right? And then we have to proceed the root array. In a similar manner. Okay guys? So you can see that. So guys, that's all from this particular session. So we have discussed the two cases and the difficulties to overcome those two cases, or method to overcome those two cases. Once again, I am repeating those two cases. The case 1, where the first row of any row is 0, the first element of any row first element of any row is 0 and the rest of row is non-zero. So the next row cannot be determined because a division of 0 will take place. So we will not be able to determine the next row, right? Next row's elements or complete next row, and in this way the root test fails. Then the method to overcome, there can be three methods. S equals to 1 by z, that is equals to 1 by x. This can be replaced. S can be replaced by inverse of certain variable, and the complete root array can be completed in terms of z or x, and the root criteria can be applied. The second thing that we can do, we can multiply the equation with s plus a, where a ranging from 1 to 3, 1 to n, whatever we want to take. We are simply inserting one pole and we are again checking the route array. It is a mathematical tool that we are doing. Why this case is appearing? This case is appearing because the first two elements are same of both the rows. So naturally the next element is going to become 0. So we want to just mathematically arrange this particular equation, this particular coefficient, so that the system characteristics doesn't changes, but the stability can be investigated. So what we have done for that, either method 1 or 2 or method 3, we can follow any three method to determine the stability. Method 1 and 2 are actually shifting the coefficient. We have seen this method 2. Method 1, where we have replaced s by z, so the coefficients now shifted, they have just inverted, so that now the row of the first element is not 0, it is a non-zero element, and subsequent rows can be computed. Okay, similarly the entire row above s to the power 0 is there. If entire row above s to the power 0 is there, then what is going to happen? That means now we have to check the stability. So for checking the stability, we have to form the auxiliary equation. And auxiliary equation, using the auxiliary equation, the new rows can be determined by taking the derivative of the auxiliary equation. And it is for sure the root of row of 0 is appearing. That means there is certain thing about marginal stability is appearing into that particular system. Now we have to check whether the column sign is negative or positive. If the column sign is positive, all the first elements are positive or first elements are having same sign, that means the system is marginally stable, but it is not unstable. But if it is sign changing is there, that means the system is unstable. So that can be checked using route array. So guys, here I am going to stop my session because it's all about the special cases. Then tomorrow, in the tomorrow session, we are going to cover some numerical on GATE, and then we are going to discuss the applications of route criteria, some of the applications of route k, especially determining the range of value of k, determining the marginal gain, determining the frequency of oscillation. All these things we are going to discuss. Next, if you have liked our session, before we conclude, right, we conclude with a very good remark, that is, forget the mistake, remember the lesson. Guys, always we have to forget the mistake and we have to remember the lesson. Always be positive. So Unacademy Combat Quiz is going live tomorrow, that is 28th of February 2021. Use my code RAJAT11 to unlock this particular quiz and get the benefit of a scholarship in terms of 85 lakhs rupees in terms of subscription. Okay. You can join India's #1 study channel, Creatrix GATE, Unacademy GATE, Unacademy GATE Civil Engineering, Unacademy GATE Telugu Session, Unacademy SSC JE, Unacademy Computer Science, Unacademy Questions, Unacademy GATE Electrical Junction, Unacademy Engineering Pathshala, Unacademy Engineering Foundation and Engineering Pathshala. These are the #1 study channels, guys. Unacademy is the #1 platform of India who has brought so many educators together and giving this service to you people. So thank you very much. Please like, share and subscribe and hit